Polygon properties and parallelograms. We're going to begin today talking about the properties of all polygons. Then we'll focus in particular on parallelograms, which turn out to be one of the most important shapes because a lot of other polygons get their properties from a parallelogram. Beginning with polygon shapes. Polygon means a many-sided figure. The first one we look at is a triangle. We've talked about triangles. The second one is a quadrilateral. That one's a square, but a quadrilateral is a polygon with four sides, like a rectangle or a trapezoid or a rhombus. We'll talk about those later. A pentagon is a five-sided figure. A hexagon, six sides. Seven sides is a septagon or a heptagon. Sept means seven. Just like September literally means seventh month. It's not, but that's another story. Octagon is eight sides. October, yes, means eighth month. Nonagon is nine sides. Decagon is 10 sides. Deca means 10. December means 10th month. Interesting, huh? And dodecagon is a 12-sided figure. There's probably a name for an 11-sided figure, but we don't talk about that. All the figures on the previous page were regular polygons. Regular just means all their sides are equal and all their angles are equal. A regular triangle is an equilateral triangle. A regular quadrilateral, that's a four-sided figure, is a square. The figures on the previous page and the figures on this page happen to be regular polygons. A regular polygon is a polygon which has all congruent sides and congruent interior angles. A regular triangle is an equilateral triangle. A regular quadrilateral is a square. This five-sided figure is a pentagon, and it's regular. All sides and angles are equal. The 6, 7, and 8 there are all regular too. Regular is an important vocabulary word. You got to know this. It turns out that it's fairly simple to find the sum of the angles of a convex polygon. Convex means all sides are outward. It's not caved in. We'll talk about that in a minute. But look at all these shapes. The trick is to realize the sum of the angles is 180 degrees in a triangle. And if I want to sum the angles in any quadrilateral, I can pick a vertex and draw on a diagonal, and I end up with two triangles. And each of those triangles is 180 degrees. So this one ends up being 2 times 180. The pentagon, if I pick one vertex, it can be any vertex, and draw in the diagonals, I get 180, 180 degrees, and 180 degrees. And it ends up being 3 times 180 for the sum of the angles in a pentagon. And that happens to be 540 degrees, just like the quadrilateral is 360 degrees. For my hexagon, I pick a vertex and I draw in all the diagonals. There's 180, 180, 180, and another 180. And the sum of all those inside angles is the sum of the angles in the triangles. It ends up being 4 times 180, which it happens to be 720 degrees. This seven-sided figure, a heptagon or a septagon, notice that 1, 2, 3, 4, 5. There are 5 180s. And by this time, maybe you're noticing there's a pattern. It happens to be 900 degrees. 2, 3, 4, 5 triangles. This one must have 6. 1, 2, 3, 4, 5, 6. So it in fact is just 6 times 180. 6 times 180 is 1080 degrees. Now the thing you need to notice is that there's a relationship between the number of sides, which happens to be the same as the number of angles, by the way. Look at the triangle. It was 1 times 180, and a three-sided figure had one triangle in it. The quadrilateral was 2 times 180, and a four-sided figure had two triangles. The pentagon, the five-sided figure, had three triangles, and the hexagon, a six-sided figure, had four triangles. A seven-sided figure had five triangles, and an eight-sided had six. And what you should notice is that the number of sides minus 2 is the number of triangles. The number of sides minus 2 times 180 is the sum of the interior angles. And that's where n is the number of sides. I mentioned briefly on the other page that this n minus 2 times 180 only works with convex polygons. A concave polygon, like this one, is caved in. See how I can connect two vertices and have points that are inside that created figure? That's what makes it caved in. We talk about convex polygons, and in that case, it's just not caved in. N minus 2 times 180 is what you got to know. Remember that n is the number of sides. It's also the number of angles and the number of triangles like we showed on the previous page. That means if it's regular, remember a regular polygon has all equal interior angles and all equal sides. If I take the sum of all the angles, n minus 2 times 180, and divide it by n, the number of angles and the number of sides, what I get is one angle. We're going to use this idea here. Take the sum of all the angles. If it's regular, divide it by the number of angles, which is the number of sides, and we get one angle. The last thing to point out is that all the exterior angles in any convex polygon always, every single time, add to 360 degrees. Isn't that crazy? So the exterior angles are when I extend a side. We talked about that with triangles. And I'm talking about one at each vertex. So as I go around and count my vertex, I'm one exterior angle at each vertex. If I add all those angles together, every single time I get 360 degrees. This can be useful. You saw all the names we had for polygons. If they get beyond that, typically we call them a 20gon or a 25gon. It's an n-gon, where n is the number of sides. What if I wanted to know the sum of the angles in a 15gon? It had 15 sides, and it's convex. That would be n minus 2 times 180, which is 15 minus 2 times 180, which is 13 times 180. And we go to our calculator. 13 times 180 is 2,340 degrees. That's a lot of degrees. Let's find one angle in a regular dodecagon. Dodecagon has 12 sides. It was one of the named figures. So I'll go 12 minus 2 times 180, which is 10 times 180, which is 1,800 degrees. It's regular. That tells us that all the interior angles are congruent. There are 12 sides, there are 12 angles, and they're all congruent. So all I need to do is take the sum of all those angles, that's 1,800 degrees, and divide by the number of angles, which is 12, and I get one angle. And that happens to be 150 degrees. A regular polygon has an interior angle of 176 degrees. Find the number of sides. There are a couple of ways we can do this. The first is to create an equation. I know that n minus 2 times 180 is the sum of all the angles. I know that if I divide by n, I get one of those angles, and that angle happens to be, in this case, 176 degrees. If I solve this equation, I'll know the answer. I could cross multiply, that'd be a good way to go. 176 times n, 176n equals, cross multiply 1 times n minus 2 times 180, which is n minus 2 times 180. Now distribute. 176n equals 180n minus 360. Let's subtract 180n from each side. We get negative 4n equals negative 360. Divide both sides by negative 4, and I see that n is 90. Now, n was the number of angles and the number of sides. There are 90 sides in this polygon. It would pretty much look like a circle. There's another way we can do this that actually is much quicker. If I think about this 90-sided figure as I'm going around, here are my sides. This isn't to scale. I know that the exterior angles, there's an exterior angle right there, and this was a vertex, and this was a vertex, and that was a vertex, that the sum of all those angles is 360 degrees. I know that this interior angle is 176 degrees. And I know the exterior angle and the interior angle add to 180 degrees every single time if I do one exterior angle at each vertex. That means this exterior angle is 4 degrees, pretty small. If I take 360 degrees and divide by the number of exterior angles at each vertex, which are n, the same as the number of sides, the same as the number of interior angles, I know that that's equal to 4 degrees. I can cross multiply here, and I get 4n is equal to 1 times 360, which is 360. And you see how I can divide by 4 and get n equals 90. There are 90 sides. This is going to be very quick about parallelograms. Just remember the definition of a parallelogram is that it's a quadrilateral with opposite sides parallel. When we write a parallelogram on paper, we use the parallelogram symbol and we write it like this: parallelogram ABCD. You can go in either order, clockwise or counterclockwise, it doesn't matter. First property of parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. In this case, we know that BC would be congruent to AD. It's also parallel. It's an opposite side in a parallelogram. And AB is congruent to CD, which again are also parallel. Opposite sides are congruent in a parallelogram. Opposite sides are parallel in a parallelogram. Next property. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle A is congruent to angle C. They're marked in the picture. And angle B is congruent to angle D. Opposite sides are parallel, opposite sides are congruent, and opposite angles are congruent. Next property. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. This recalls something from earlier in the book. When you have parallel lines, you have same side interior angles in this shape. This and this are same side interior angles. They add to 180. But any two consecutive angles, that means next to in order, will always add to 180 because I've got these parallel lines going on both sides of the parallelogram. Any pair of consecutive angles are supplementary because they are same side interior angles. They're on the same side of a transversal and between the parallel lines. Last property, if a quadrilateral is a parallelogram, then its diagonals bisect each other. In this picture, BD bisects AC, and AC bisects BD. That means BZ is congruent to ZD, and AZ is congruent to ZC. The diagonals of a parallelogram bisect each other. You've got to get these properties down. They're going to be on the test. The definition is opposite sides are parallel. Now we know that opposite sides are congruent. Opposite angles are congruent. Consecutive angles, angles next to each other, are supplementary because they're same side interior angles. And the diagonals bisect each other. Get them down. We're going to need them in the next section too. The last thing I want to point out about parallelograms is that we have a lot of angles and properties that from previous chapters going on in the picture. We know we have same side interior angles. Consecutive angles are supplementary. When the diagonals are in there, we have alternate interior angles. There are also vertical angles in this diagram. Let's take a look at some of these angles. I'm going to make up some numbers. I can't call that angle D because there are other angles at vertex D. This whole angle is CDE, and if I made it 120 degrees, remember that CFE on the other side is also 120 degrees. Note that consecutive angles are supplementary. That means this angle would be 60 degrees. Also, angle DCF would be 60, either because it's an opposite angle to angle DEF, or because consecutive angles are supplementary, however you look at it. If I told you that angle CDG or CDF was 40 degrees, then I could subtract from 120 and figure out that angle EDG or EDF is 80 degrees. And because I have alternate interior angles, this angle here would be 40 degrees, and this angle here would be 80 degrees. They're alternate interior angles. If I told you that angle DCG, this angle, was 20 degrees, I could subtract from 60, and this would be 40 degrees. This is an alternate interior angle. It's 40 degrees from here to here. And this is an alternate interior angle. It's 20 degrees. Now, if I look at a triangle like CDG, I have 20, 40. I can subtract from 180. 20 and 40 make 60. That makes this one 120 degrees. And this is a vertical angle. It's 120 degrees. I know that these two are a linear pair. This would be 60 degrees. And this is a vertical angle. It's 60 degrees. Take a look at all the relationships. You're going to have to know them all for your homework. Here's some questions from your assignment. Find the sum of the measures of the exterior angles of an octagon. In any polygon, the exterior angles, one at each vertex, add to 360 degrees. No calculations required. Question 2. Find the sum of the measures of the interior angles of an octagon. An octagon has 8 sides, and I know that the sum of the interior angles is n minus 2 times 180. Remember, it was the number of triangles minus 2 times 180. That's 8 minus 2 times 180, which is 6 times 180, which is 1080 degrees. Question 3, you gotta love these. Find the sum of the measures of the exterior angles. The exterior angles, one at each vertex of any convex polygon, always add to 360. Question 4. Find the sum of the measures of the interior angles of an 18gon. It has 18 sides. N minus 2 times 180 is 18 minus 2 times 180, which is 16 times 180. You go to the calculator, 16 times 180 is 2,880 degrees. Question 7. Find the measure of each interior angle. That is one. They're talking about one interior angle. So what I'm going to do is take the n minus 2 times 180, which is the sum of all of them, and I'm going to divide by the number of them. The number of sides is the same as the number of angles. So if they're regular, they're all equal, and I can add them all up. That's n minus 2 times 180, the sum of all of them, and divide by n, the number of angles, and that gives me one angle, which is what I'm looking for, one interior angle. So this is an octagon. There are 8 sides. 8 minus 2 times 180. Now I'm going to divide that by the number of sides, which is the number of angles. That's n, which is 8. This is 6 times 180 divided by 8. Go to your calculator. 6 times 180 divided by 8 is 135 degrees. Each interior angle of a regular octagon is 135 degrees. Another example, just like the last one. Find the measure of each interior angle of a regular quadrilateral. Well, this one's fairly easy. You might already know what a regular quadrilateral is, but again, you take n minus 2, which is 4 minus 2, times 180, and then you divide that by the number of angles. What's a quadrilateral? There are 4 sides and 4 angles. This what ends up being 90. What's a regular quadrilateral? A square. 90 degrees. This is like the last one I did in the teaching. There are 2 ways to do this. I'll do it both ways and you can choose which one you like. N minus 2 times 180 is the sum of all the angles in a regular quadrilateral, in any quadrilateral, but this one's regular. So all these are going to be equal. Now if I divide by the number of angles, that gives me one angle, which is 156 degrees. I can put that over 1 and cross multiply. That's 156n equals 1 times n minus 2 times 180. I'm going to go ahead and distribute. That's 180n minus 360. And I'll subtract 180n from each side. 156 minus 180 is negative 24. Negative 24n equals negative 360. Now I'll divide both sides by negative 24. And we get 15. This thing has 15 sides. It's a 15gon. 15 is our answer. The other way we could have done this, which is slightly easier, but you have to understand, is that here's my quadrilateral, and this is the interior angle, 156 degrees. I know that if I extend a side, I get an exterior angle. And I know that these two angles add to 180 degrees. If I take 180 and subtract 156, I get 24. So this is a 24-degree exterior angle. All the exterior angles add to 360 degrees. And if I take one at each vertex and I divide by the number of them, there are n of them, there are n interior angles, n exterior angles, one at each vertex, and n sides. So 360 is the sum of all of them. If I divide by n, I get one exterior angle, which is 24 degrees. Put that over 1 and cross multiply. 24n equals 1 times 360, which is 360. Divide both sides by 24. And we already did 360 divided by 24. Remember, it was 15. Another example, a lot like the last one. I know the measure of an exterior angle, one of them, and a regular polygon, they're all equal, is 108 degrees. N minus 2 times 180 is the sum of all of them. If I divide by the number of them, I get one interior angle. Now we'll put this over 1 and cross multiply. 108n equals 1 times n minus 2 times 180. The 1 doesn't do anything, and I'll distribute the 180. It's 180n minus 180 times 2 is 360. Subtract 180n from each side. 108 minus 180 is negative 72. So that's negative 72n equals negative 360. Divide both sides by negative 72, and we get n equals 5. So this is a pentagon. The other way you could do that question is just to understand what an exterior angle is. My polygon always goes around with straight sides, and it's regular. I know this interior angle is 108 degrees. So if I extend a side, I get an exterior angle, which happens to be 72 degrees. I know all the exterior angles add to 360 degrees. If I divide by the number of them, which is n is the number of exterior angles, the number of interior angles, and the number of sides, what I get is one exterior angle. They're all equal because it's regular. I can cross multiply. N times 72 is 72n. 1 times 360 is 360. Divide both sides by 72, and you get n equal 5. You have several like this. This is finding different angles, and you're given 3 angles, so let's label them. You should draw a picture for this one to figure it out. VHL, that's this entire angle, is 78 degrees. HLV is 25 degrees. That's this one. And KHL is 54 degrees. Let's find every angle we can. Alternate angles, this one's 25 degrees. Alternate angles, this one's 54 degrees. I know this entire angle was 78, which means this entire angle is also 78 degrees. And 78 minus 54 is 24, so this one's 24 degrees. This is 24 degrees. It's an alternate interior angle. We know that consecutive angles are supplementary. If this whole angle is 78, whatever this whole angle is right here, these two have to add to 180, which means it's 102 degrees. Now I can take this 25-degree angle and subtract it from 102. 102 minus 25, and I get 77 degrees, which makes this one 77 degrees. Now that I have all the angles on the outside, I can find these vertical angles in the middle. I can take 54 and 25 and subtract from 180. 180 minus 54 minus 25, and I get 101 degrees. This is a vertical angle. It's 101 degrees. We have a linear pair right here. 180 minus 101 is 79 degrees, and this is a vertical angle. It's 79 degrees. The first angle we're looking for is angle KLH. KLH, which is this entire angle. Well, we found that it was 102 on the other side. It's 102 over here, too. Opposite angles of a parallelogram are congruent. KLV. KLV. We got 77. VKH. VKH. Well, that's right here. It's 54 degrees. VNK. VNK. It's one of the angles in the middle. It's that one right there, 101 degrees. Question 21 is a bit easier than the previous question. You just have to remember here that the opposite sides are congruent and that the diagonals bisect each other. They cut each other in half. Given that EJ is 50, that means MF is 50. Opposite sides are congruent. That FE is 30. That means that MJ is 30. JF, that's this entire diagonal, is 70. That means each piece here would be 35. And MP, I'll change colors, is this little piece right here. It's 44, which means this piece is 44. And this entire diagonal from here to here would have been 88. Looking below, MF is 50. MJ is 30. JP is right here. It's 35. And EP is from here to here. It happens to be 44. The important thing about question 29 is to draw a picture. Just draw a parallelogram, any old parallelogram, however you want. Opposite sides are parallel, opposite sides are congruent, etc. And label either clockwise or counterclockwise. You need to go in order. H, L, E, B. Which statements are true? HL is parallel to BH. Well, that's certainly not true. We know that HL is parallel to BE. This one's out. HE, that is a diagonal, bisects BL. The other diagonal. And that would be true. True. Angle L, now that's before the diagonals, this whole angle would be congruent to angle B. Now they're talking about from this picture. I drew in the diagonals. Remember, you can't call those L and B if you draw on the diagonals, because then you have more than one angle there. But this is a true statement as long as I don't draw on the diagonals. Angle H is supplementary to both angle E and B. Well, angle H and angle E are congruent. So it's not supplementary to both of these. It might be supplementary to B, but it's not to E. So this one is out. And these two are our correct answers. Last one here is question 35. All you need to do is recognize that it's a parallelogram. These opposite sides are parallel. That means this angle and this angle are alternate angles. They're congruent. So the measure of angle 1 is the same as the measure of angle 2, which means that x plus 15 is equal to 6x minus 20. Let's solve that quickly. Let's take an x off each side. 15 equals 5x minus 20. Add 20 to both sides. 5x equals 35. Divide both sides by 5, and x is 7. Find the measure of angle 2. Angle 2, the measure of angle 2, was 6x minus 20. That's 6 times 7 minus 20. Now that's 42 minus 20, which happens to be 22. The measure of angle 2 is 22 degrees.